Okay, let's start. Welcome, everyone. Today's session is about AI vision and how to improve product quality. But before we start, let me introduce myself. My name is Marina. I will be the host of today's session, and I have a very easy to follow housekeeping rules for today. The first one is about the Q&A functionality. You can find this button at the bottom of your screen. It's an icon that says Q&A, not to confuse it with the chat. And you can drop your questions anytime. We will address them at the end of the session. Second part is that the webinar will be recorded, and the recording will be shared with you after the session. So you can expect an email coming from us tomorrow. And the session will approximately last 30 minutes with time for questions at the end. Some interesting information I wanted to share with you all is that we receive interest from across the board. And I do want to welcome everyone who is either on this live session or who's going to watch the recording. We are talking to people from Australia, New Zealand, up to Canada, United States, Colombia, Argentina, Egypt, Turkey, UK, you name it. So welcome. But today is about the information that these three gentlemen will share with you all. They bring more than 25 years of experience, and I invite you to challenge them with your questions. I'm happy to introduce Guillaume to you. He's coming from Cognex, and he's going to be covering the second part of the webinar. Stephen from Markem-Imaje, who's going to be covering the first part of the webinar and the use case, and Stefan, who's also from Markem-Imaje and who's going to be doing the live demo. So no further ado, the floor is yours, Stephen.
Thank you much, and welcome to everyone. So why are we here? I mean, I spend a lot of my time walking around factories, talking to customers, and I see lots of different things on packaging lines, wrong materials, missing codes, incorrect data. And Markem-Imaje, we've been doing inspection for many years. But also what I also see a lot, particularly on LinkedIn and social media, that AI is everything. It's AI this and AI manufacturing. But what I see a lot of is that people don't really come with real solid use cases for AI. And I felt this would be an opportunity for you to show something that's a genuine use case in manufacturing for AI, and show you some real life examples and some real life technology from my colleagues as well. So next slide, please, Marina. So just a little bit about Markem-Imaje very briefly. We're an end-to-end solution provider. We build the printing and hardware equipment. We also have our own software platform, which is fully integrated into Cognex. We do enterprise integration, and we're very specialized. We focus on packaging and production lines, and we've been doing that for over 20 years in software solutions as well. Next slide, please, Marina. So this is some industry data. This has been gathered from my experience visiting customers, asking customers what they experience. And what we see the most is wrong packaging, wrong product, incorrect labels, incorrect caps, that type of thing. Seems to be the highest cause of problems in manufacturing production lines. Next guilty culprit is missing codes, wrong master data. Now that can be various different things. We have some customers that take data from SAP on a piece of paper and type it into equipment, which is always problematic, or the master data itself can be incorrect as well. Missing pallet labels is also very popular, and other reasons, which is kind of the leftover parts that we don't really know about as well. So, but I would be very interested to get your information and also tell me what you see on your production lines or in your factories. So my colleague Marina is going to pop up a quick poll. I'd be really interested if you could just click an option and let us know what your biggest problems are. Unfortunately, we can't vote in this, so. Cool.
Cool. I see a clear winner. Just giving 10 more seconds. I'll end the poll.
If it's over, I will be disappointed.
Sharing the results.
Oh, missing codes. Excellent. Interesting. Yeah. Great. I appreciate that. That's great to get that data. Great. Excellent. Next slide, please, Marina. Okay. So I picked this as kind of a customer use case. I particularly picked the milk bricks because they're quite problematic. They're not the squarest object in the world. They generally can be susceptible to vibration. They're also generally in a wet environment, so they can slip. So obviously, when you're printing on this type of material and object, it can be quite problematic. And this kind of lends itself to, like a real good example why AI vision is different to, say, standard rule-based vision as well. And this was some averages that were taken from a production line, but the customer was averaging rejections up to 2,000 per lot of 4,000. So you can imagine this is quite a high percentage. And was causing a lot of issues on the line, having to rework, damaged products. So this is a nice this brick is a nice character to base an example on as well. Next slide, please. So customers currently using rule-based inspection. And these would be the kind of standard rejections we'd see during your rule-based inspection. Water on the text, curved text, scratches, which also standard OCR doesn't like, and obviously some things are actually genuine rejection as well. False trigger, no print at all, or the prints out of the actual print window as well. So these are kind of what we'd expect on these type of lines, and this is what we've experienced for many years with standard vision as well. So moving to the next slide, please. So this is kind of just the rejections per unit. Obviously, you can see that curve prints was a big culprit, and outer print areas was also an issue. Scratches, obviously, that's also had an impact as well, and splashes and blurred images as well. So go to the next slide, please. So with smart OCR or intelligent OCR or edge learning, we're allowed to, also because you take the cameras and you actually teach them what's acceptable. So a standard OCR would reject curved text, even if it's human readable, it would still reject it because it's not quite perfect. So with the new inspection style and technology, you could actually encompass curved text into a non-reject category, and also you can ignore scratches and marks to a certain extent. Obviously, if a scratch and mark actually damages the text or defaces the label, then obviously that would be a genuine reject. But it allowed us to bring some new categories in. And these curved text is common in milk bricks, but also films and other materials as well. So this is a nice example of how you can reduce your rejection rates and obviously get more product out of your production line as well. So you want to go to the next slide, please? Yeah, so for this example, hadn't taken the old technology away and bringing in the new technology, we're able to reduce the rejection of curved prints, reduce some of the scratch areas, but the genuine rejections stayed in place. So it amounted to a reduction about 40% of rejection, which is a huge impact on the labor, the effort, the damaged products, and the output of the production line as well. So from an adoption of a new technology, it allows the OEE and the output of the line to be generally increased by a decent amount. So next slide, please. So what's the benefits of AI? Obviously, we talked about the benefits of having less rejection. That's important. But also AI is easier to configure. It's less of a science project now. It allows you to teach the camera compared to a rule-based solution. It also makes it more robust. Means it's less susceptible and easier to maintain to slight variations in the environment, where the older systems were a little more sensitive. And yeah, I think it overall benefits. And I have this personal rule. When you install a vision system, it's there to solve a problem, not create problems. And I've seen many systems that have been installed. They worked quite well for a while, and then obviously it becomes more problematic. It does a lot more false rejections, and generally sometimes you can find that the operators may disconnect the cameras, or they may be disconnected from the actual production line as well. So with AI allows a more robust and kind of a more system that would withstand more variation and allows us to operate in a more industrial environment as well. So next slide, please, Marina. I'm going to hand over to my colleague from Cognex.
Thank you, Stephen. Thanks. Do you hear me correct? Yeah?
Yep.
Perfect. Good afternoon, everyone. Thank you for joining this webinar. I'm Guillaume Paissé. I've been working in machine vision for over 25 years, including the last 18 years at Cognex. And during that time, I can tell you I've seen several waves of innovation, but nothing that compares to the topic of today. Machine vision is really going under in its biggest transformation in decades. And AI, artificial intelligence, is disrupting what we know is traditional rules-based inspection and fundamentally changing how vision systems are designed, deployed, and maintained. So what I want to do over the next 30 minutes is showing you what this transformation really means, with explaining the technology, exploring where AI delivers clear advantages over traditional machine vision. We walk you also through a live demonstration, and we will finish by discussing what it takes to deploy a reliable and scalable AI vision solution across multiple production lines and manufacturing sites. So if we go to the next slide, let's frame the question we are really here to answer today. How can AI vision help you improve quality inspection? Throughout the session, think about your own applications, where the tricky defects, the parts that vary, the inspection that took weeks to program. By the end of this session, my goal is that you all know when AI vision is the right tool and how Cognex and Markem-Imaje bring it together into one solution. So let's get started with an analogy I love. Think about how you would teach a child what a house is. There's no perfect golden definition. Does it need a door, a window, chimney, balcony, garage? You wouldn't list a long set of rigid rules because they break down at the moment you are in the real world. So instead of that, you show the child many different houses until they form a concept that can adapt to variation, any variation they've never seen before, of course, and you give feedback on the confusing cases. AI works exactly the same way. It is an example-based training modeled on human learning rather than a rigid rules-based solution. Next slide. This one is a boring one, but before we talk benefits, let's quickly just demystify what's under the hood. And AI at its core is about neural network. Imagine the raw data, in our case, the pixels of an image comes in through the input layer. Then it passes through a series of hidden layers that are each extracting some abstract patterns. And finally, in the output layer, it produces a decision. It can be defect or no defect. It could be a classification label or a confidence score when it is about reading characters. There are a few common architecture that I will not go into the details of training approaches for each of these, but rather I want to explain to you why are these neural nets so powerful. There are three reasons. Number one, they can really model extremely complex non-linear problems. So it's not A to B, but it's non-linear. And rules can't simply express that. You cannot do it with rules-based. Second, they learn the right features automatically, so you're not hand engineering them. And third, these neural nets keep getting better as you feed them with more labeled examples. These are the three reasons that make neural network technology so powerful. So on the next slide, yeah. So what does that mean for machine vision? It's a data-driven approach. Instead of rigid rules, program rules, the system learns from example images. Then it operates as an experienced human inspector by interpreting the visual information and making decisions. And critically, it doesn't require the user to be a vision expert or to spend days in tuning endless parameters. It is the real shift from programming to teaching. Now, if we can go, the next one is the preferred of Stephen. The classic example of why programming rules fall apart is the muffin or chihuahua example. You know? At a pixel level, when you look at these images, they are remarkably similar, same color, same blob, same texture. There is no reasonable set of criteria and threshold that can separate them reliably. But a trained AI model, like a human, picks up the subtle patterns and they get it right. That's exactly the kind of problem AI vision solves better than rule-based vision.
I'll add a point there. They both taste completely different.
Definitely. Yeah, next slide, please, Marina. So AI simplifies and solves what traditional vision makes complex. Let's make it concrete. You know, complex inspection often need hundreds of rules, thresholds, and exceptions that are expensive to build and painful to maintain. Then rule-based vision is great when parts are consistent and well-made. But the moment you hit large defect libraries, many exceptions, product variation, you're fighting confusing criteria, complex thresholds, it creates a high risk of false reject. AI is flipping that around by learning directly from the production data. It gives you faster implementation, quicker time to value, lower engineering and maintenance effort, and a much greater resilience to product and process variation. So AI vision brings smart and agile decision-making together with speed and consistency. This is the benefit is from the machine side, you get speed, consistency, repeatability, because a machine never gets tired. And from the human side, you get the tolerance to variation and the ability to learn from just a handful of images. So on the next slide, I can show you, in addition, I just told you that AI simplifies and solves what traditional vision makes complex. Now, let's see how Cognex turns this into a fully industrialized solution. You know, our third generation of Cognex AI pushes further the industry-leading performance without adding development complexity. And this is very key. You know, more performance, less complexity. So you gain on the two aspects. How do we achieve this? We do it through two key principles. Number one is designing purpose-built AI tools for specific application needs. Locator, segmenter, classifier, anomaly detector, OCR. And then second principle is opening those tools to flexible operating profiles that are adapting to the different deployment requirements. Means few sample mode, high detail mode, pre-train mode. So we push the tool specificity with an openness for configuration. So we match the application and the type of use case. And here is an example of a highly complex traditional inspection, which gets trivial when addressing it with Cognex AI vision. Now, the AI classifier only requires few handful images per class. Only 2 or 3 are very often enough. And it enables solving this application in minutes versus weeks. And it makes evolution safe and almost effortless, as a new class creation is easy and do not impact the other classes. So you can find the same type of application in many industries: beverage for container inspection or cap identification, medical for kitting, pharmaceutical for instruction leaflet presence, or food industry for allergen management, SKU identification for labeling. Plenty of similar use cases are happening in every day in the industry. Next one. So AI is not answering to everything. Let's be honest about that. For applications that need precise measurements, like gauging, robot guidance, high repeatability against exact criteria, rule-based tools are still the right choice. AI vision really shines for reading codes, characters, defect inspection, anything you'd rather train from example than configure by hand, and anywhere you need tolerance to variation. This is really the use case for AI. The good news is that Cognex system contain both rules-based and AI tools, so you're never locked in, and you can pick the right tool for each job, and you can combine them when needed. So let's go on a few application examples. Here are a few application examples showing AI reading performance versus any kind of printing technology, skewed characters, inconsistent spacing between characters, low contrast, inconsistent background, curved surfaces. So I think, Stephen, your use case was really showing the benefit of AI decoding versus rules-based. There are plenty more examples on this one. Next slide. Further examples to demonstrate the robustness and the inspection capabilities for transparent and reflective packaging. The reliable performance in applications such as kitting, filling, sealing, assembly, labeling, all with an intuitive, easy-to-use workflow that simplifies the deployment and the operation. And on the next slide, I have further example highlighting robust performance also in SKU identification, kit completeness check, part counting, assembly and marking applications. So yeah, the scope is very large. But I would like to shift now with enough theory and leading you to the live demonstration run by Stefan, showcasing the minimal setup needs and the immediate operational value based on standard application case you get with Colos solution. Stefan.
Thank you. Hello, everybody. Let me sharing my screen. Do you see it? Okay. Yes. So let's imagine that you have several production lines, and you go to your production line where you have the camera already in place. Just have to move to the live view. And let's start by having write a good image. So if I trigger, okay, I have more or less my samples. I have just to make an autofocus. And we can also apply the high dynamic range tools algorithm to improve the image. Exists also the high dynamic range plus, which improve a lot and much faster than the standard HDR algorithm. So when we have a nice image, we can place a pattern on it to facilitate the location of the print. So let's take the JTIN and lot as a pattern like this. If I move my samples until it stays in the field of view of the camera, we can follow the product. Next, let's start reading the text by adding a region, edge learning generation. So it's based on AI. Read the complete text. Okay, it takes time the first time to compute everything, but now without any teaching any characters, the camera is able to read it. And if I move the product, everything is aligned based on the pattern. Okay. So let's do the same with the QR code. So I enable the QR code, define the region where the QR is, and that's all. Now the camera is able to read it. And if I continue moving the product, every tools move according the position of the pattern.
In a sequence of few clicks, in fact, you've built your application from scratch, from image formation up until even the GS1 2D code. And
yep.
that's really, in fact, it's a very short demo, but it really shows what is happening in the field. When you are visiting a customer, it's the pre-trained OCR, AI OCR is deploying out of the box with low issue. Maybe you can show how you adapt with the different pre-trained models if you go into your menu for AI read.
Okay.
Yeah, this one.
Yeah, this one. Okay. Yeah. There's 3 different pre-trained modes, and if with these 3 different pre-trained modes you are not cannot meet your requirement, read everything, you can also add move to the user train mode and add your characters when some are very specific and not able to be covered by the pre-trained model.
Yeah, awesome. It's quick but very effective. Thank you, Stefan, for demoing.
You're welcome. So I stop sharing.
Perfect. So yeah, to recap this first half, AI transforms machine vision from rules-based programming into data-driven learning, and this makes inspection faster to deploy, easier to maintain, and more resilient to variability. That's the benefit of AI. But here is the honest question: is great inspection alone enough for a successful rollout across your facilities? And usually the answer is no. So now I propose to just go a few slides and zooming out and look at the attributes that really matter when you're choosing a global traceability solution. Maybe next slide, Marina. And it starts, of course, the first pillar is the vision technology in use, not limited to the AI tools. Cognex brings industry-leading performance, application coverage, and ease of use through a unique combination of broad range of devices, sensor, speeds, with advanced image formation. That was something that Stefan showed. Only clicking on the option HDR+, which is a patented one, it gives you a fully different image. So this is really image formation is very important. Even if you have the best processing technology, the range of device, the sensor selection, the speed, the image formation is very important. Of course, we also come with over 60 years in developing proven rules-based and AI tool libraries. At Cognex, we released our first AI solution 15 years ago, and we are now at our 3rd generation of solutions. And on top of that, edge-optimized computing to run AI at industrial speed, unify ecosystem of software and hardware. Together, these capabilities ensure robust performance across virtually any application, enabling customers to solve vision challenges in a simple, reliable, and seamless way. But this is not enough. I think it's part of the story. If you can go to the next slide, Marina. The second pillar is services, and this is often where deployment succeed or fail. And Markem-Imaje offers software services, integration services, education to support your teams by bringing Cognex and Markem-Imaje together, Colos unified solution wraps the technology in the service that guarantee your global deployment that actually succeeds. Next slide. And that's actually what Colos solution is. It's a unique combination of Cognex industrial machine vision leading expertise and Markem-Imaje global traceability excellence brought together within one unified solution. So that two leaders, one platform designed to guarantee your global deployment success. Concluding on what does it delivers to you? 4 key benefits. Now, first, faster, lower risk of AI deployment with image-based learning, pre-trained models, predictable performance, and expert guidance to accelerate adoption. Second is greater operational efficiency through the high-performance edge AI, high throughput, lower scrap, rapid adaptation to new products and defects. Third is about reduced maintenance effort with continuous learning, built-in analytics, comprehensive training, and global service and support, minimizing your dependence on specialized vision experts. And last is about future-proof scalability with a common AI platform that enables model reuse, standardized deployment, and knowledge sharing across stations, lines, and sites. And the result is a solution baked by technology, education, and expert support that accelerates time to value, reduces engineering and maintenance costs, protects long-term performance, and delivers a lower TCO over the entire system lifecycle. So thank you all for your time and attention. I think if you want to learn more, you can still visit our website. There are plenty of white paper guides and on this technology. Handing over to Stephen for the conclusion.
Great. Thank you very much for all your time. I'd really like to get some questions. Please don't be shy, drop them into the chat. I'd like to see what you've got to say. I think there's one question there. I know, David, hope you're well. I'll answer this question. I know. Yeah, we can actually do inline.
So just for context, I'll read out the question.
Okay,
David is wondering how AI-based vision can improve the inspection of QR codes, especially if they need to comply with GS1 standards, including validation and verification, which is more rule-based.
Yeah, we've trialed it and also we've demoed it. I think during the GS1 event, we can do scoring of the GS1 code. So not only can we validate the data is correct against master data, which is very important. Always have the right point of reference to validate your data, and obviously we can also score that 2D code as well, because obviously it's very important that it's scannable in the retail environment. And as we all know from experience, retail scanners are not the highest level of optics, so it needs to be at a certain grade and a high quality, and ensure that it doesn't fall down in the supply chain as well. So yeah, it will hopefully improve the GS1 experience as well.
Adding maybe a complement on this
Yeah.
question. AI vision is a complement for code reading. Of course, scoring and reading are rules-based tools, but finding the code, improving the image quality is done via AI. So all of the code readers and cameras, vision cameras, are running AI tools before the GS1 read, validation, and scoring.
Yeah, that's a good combination. So.
Perfect. We have another question. Here it says, AI requires intensive processing. Is there a limitation with operating AI in smart cameras at production speed in fast-consuming goods?
Well, this one is a good question. We have a large portfolio of devices, and yeah, definitely AI is intensive. And what we run in our smart devices is edge AI, which means that the neural network is pre-trained and runs in the camera. And we have different type of processing units that adapt to variation of speeds. The latest generation that we released a few months ago, the 3900 family, is running the AI tools as fast as the traditional tools. So it means that today there is no difference with a good hardware running an AI tool or a traditional vision tool.
Thank you, Guillaume. I think we're going to answer the last one and we'll wrap it up. Steven, I think this one might be for you. Can the system do any analysis or reports on rejections?
Yeah, what we can do in Colos, we can log like obviously good and bad parts, but we can also store bad image. So we can choose to store a rejected part and archive that into a repository. So anyone from quality can look at the statistics per the batch, but then also they can look at, maybe the images that were stored of the rejection and maybe do some analysis. Is there something happening on the line? Is another piece of equipment causing the problem down the line? So yeah, we can collect that data as well. So yeah, it is available.
Thanks. Okay, and I think the last one. Do I need to contact both Markem and Cognex for solution validation? How is your partnership working?
I'll answer that one. Yeah, you contact Markem-Imaje because obviously we're the complete solution provider. We'd come to site, do an analysis, and also we'd pick the Cognex technology that we'd use as well. So, I mean, we have our own vision labs and sampling. Cognex is our technology partner, but we take responsibility for the projects as well.
Perfect. Well, if we don't receive any more question, one last one. Does it work on Colos 6 also?
Yeah. I mean, V7 is the new version of Colos, but the cameras are supported on 6 and 7. Yeah. So.
Okay.
I mean, actually, the intelligence is in the camera. We have a philosophy within Colos software is that this sounds terrible, like dumb software, smart camera. And the reason for that, we wanted to purposely move away from having heavy industrial PCs on the lines and a camera that's got no intelligence. None of my customers want hardware on the line anymore. They want PCs and desktops. They want the intelligence in the camera. Colos is a thin client. It runs on tablets, devices. It doesn't need an install. So it's the best approach for us in a technology point of view, and also an operational view as well for the customer as well.
Thank you, Steven. And thank you, Stefan and Guillaume, for today's session.
You're welcome.
Excellent. Thank you very much for hosting us, Marina. Take care.
A
Bye,
pleasure.
everyone.
Have a
Bye.
nice day. Bye-bye.
Thank you. Bye.